This is Mrs. Dawson. Use properties of parallelograms and algebra. If QRST is a parallelogram, find the value of x, of y, of z. QRST is a parallelogram, which means we know that segment QT is congruent to segment RS. QT is congruent to segment RS because opposite sides of parallelograms are congruent. Since the segments are congruent, their measures are equal. So QT equals RS. The length of QT is 3x. The length of RS is 42. Dividing both sides of the equation by 3, x equals 14. It's a little sloppy. Let's clean that up. X equals 14. Okay, it's clear. Writing off the diagram and move on to find y. Y is located right here on the diagonal. Actually, we see two expressions with y. TP, segment TP, is congruent to segment PR. TP is congruent to PR, and that's because diagonals of parallelograms bisect each other. Since the segments are congruent, the lengths are equal. So TP equals PR. The algebraic expression for TP is 4y minus 7. The algebraic expression for PR is y plus 11. So these two are equal. Subtract y from both sides and add 7 to both sides. Divide both sides of the equation by 3, and y is equal to 6. Let's clean the diagram and look to see where z is located. Z is part of the measure of angle PST, and then we have another measure of angle TQS of 84 degrees and angle SQR of 45 degrees. Let's use red. Triangle TQS is congruent to triangle RSQ. Let's take a look at that. Triangle TQS is congruent to triangle RSQ. And that's because a diagonal separates a parallelogram into two congruent triangles. So angle QST, which is right here, is congruent to angle SQR. SQR, right here. Which means their measures, the measure of angle QST equals the measure of angle SQR. The measure of angle QST was given as 2z. the measure of angle SQR, SQR was given as 45 degrees. Which means if we divide both sides of the equation by 2, Z equals 22.5, or 22 and 5/10. So, X was 14, Y equals 6, and Z equals 22 and a half.